everyone, welcome back to my channel. So this video I'm going to be going through factors which influence the shape of our coastline, but this video is particularly going to focus in on the geology or rock type and various erosion processes in relation to those coastal landforms we find. So if you're finding these videos useful, please remember to like and subscribe. So the coastline is very unique. We have lots of various coastal landforms that are all made through various processes and factors which contribute to their formation. We've already looked at in a previous video of transportation processes as well as longshore drift. Now this video, like I said before, is going to focus in on rock type and erosion. So when we study various rock types that we find on our planet, this is linked to the subject of geology. And geology is the study of the Earth's history and its physical features. And one thing that geologists can study is rocks. So what I have here are some examples of various rocks that we can find on our planet as well as along our coastline. So let's have a look at each of these rocks in turn to just have a better understanding of the different types of rocks that we find on our coastlines. So this rock you can see here is called basalt, and basalt is very dark in colour and it has very fine grains, meaning that the parts that make up this basalt rock are very small. Now basalt is actually one of the most widespread igneous rocks that we find on our planet, and it's formed through the cooling and solidification of magma or lava. In terms of its touch, it's very, very smooth and it's quite a dense, heavy rock. Now the second type of rock we're going to look at is called granite. You might have already heard of this one because this is a type of rock that we will typically use on bench tops, counters, monuments, headstones, maybe even statues. Now granite is usually very light in colour and it is made up of some of the oldest known rocks on Earth. And this particular type of rock can be found under the Earth's surface, where it is cooled, causing minerals to grow. And if you look closely at the actual grain size of this particular type of rock, it has a very medium to coarse grain size. The particles are a lot bigger in comparison to the basalt rock we were just looking at. Next up, let's take a look at some slate. Now slate is a metamorphic rock, and it's formed when we have these fine-grained sedimentary rocks like shale buried and exposed to very high pressures deep underneath the Earth's surface, which creates the individual layers that you can see on the screen. Now to touch, slate is actually very smooth, and we use it for lots of different purposes like roof tiles, blackboards, sometimes even snooker or billiard tables as well. And this particular type of rock is very fine grained, but it tends to be very hard and very brittle. Now let's take a look at another metamorphic rock. Let's take a look at some marble. And marble forms under conditions which create rough crystals like you can see here, which are medium in size, due to being compressed over time. Now marble can actually be made up of a variety of colours due to the impurities found in the ground or dirt when being formed. Now although marble can appear very hard, it's generally very gritty when you touch it, so it's not very smooth. It can also be scratched by metal blades, which is why we tend to use it in building work, paving, monuments and even headstones. But when it comes into contact with hydrochloric acid, it will cause a chemical reaction and cause the marble to fizz. Now the final type of rock I have here is a sedimentary rock known as sandstone, which is typically formed from sand-sized particles being held together with something called calcite, which is pretty much like a glue, which binds the particles together. Now when you actually touch sandstone, it is very gritty, so pretty much feels like sandpaper. And in terms of this particular rock, it's very variable in terms of its resistance. So sometimes it's hard and sometimes it's soft. You can see here this particular sandstone that I have, even when I touch it, small fine particles of sand are actually coming away from the main rock into my hand. In this case, it would be considered too soft to do anything else with it, particularly if we're thinking about using it in the construction industry. But if this type of rock is very hard, then we could potentially use it in construction and also in roads. So what's this got to do with coastlines? Well, it all comes down to the rock type and its composition, and whether that rock is resistant or not to erosion, this idea of water or something else wearing it away. So the best way for me to show you how resistant various rocks are is through a little demonstration. So here we've got some granite on the right and we've got some sandstone on the left. And I'm going to show you here which type of rock in this case is more resistant to a little bit of erosion. So here I've got two jars. Each of these jars has smaller particles of the various rocks that you can see on the screen. So this jar, for example, on the left here has a small number of different pieces of granite inside it. And I've also put some water in the jar as well. Now, if I was to shake this jar over a long period of time, I would be able to see how resistant that rock is, that granite in that jar, in relation to a little bit of erosion, a little bit of wearing away from the water. And as you can see in the jar, nothing has happened. The water is still the same colour, the granite is still the same size, nothing has happened. In which case, we would say that this type of rock is more resistant to erosion. It can withstand it. But then, if we were to pick up the jar that has the sandstone in it, again, water in this jar as well, and I was to shake it to mimic this idea of erosion taking place on the coastline, you would actually see that the water suddenly appears quite murky. And this is because sandstone is less resistant in comparison to granite. It's more likely to be worn away and eroded by water and by the sheer force of the waves when it hits the coastline. So over time, if a coastline is made up of sandstone, it would slowly begin to erode. It would begin to wear away. And as you can see in the jar, we've even got smaller, tiny little pieces of sand present at the bottom already to indicate that the sandstone is less resistant to erosion and more likely to be worn away. So when it comes to the geology or the rock type on a coastline, it comes down to the resistance. Which rock is more resistant to erosion than another? Which leads us nicely on to erosion and what it actually means. So when I'm talking about erosion, I'm talking about the wearing away of material along the coastline. Whether it's marble, sandstone, slate, granite, it seriously doesn't matter. What matters is that over time, this particular material will be worn away a little bit at a time. But different rocks are more resistant to erosion and some will be eroded quicker than others. And as a result of erosion, we can get these spectacular coastal landforms created that we can see around the world. Now, there are actually 4 different ways that erosion takes place on our coastline. The first type of erosion is what you can see happening here. This is called hydraulic action. This is when the sheer force of the water hits the cliff faces present along our coastlines. The water then forces air to become compressed in the cracks and the folds and all the various openings present along the cliff edge. And as that air rushes out of those cracks, when the wave retreats or pulls back, it will lead to an explosive effect of pressure being released. And over time, the material on the cliff face will sometimes break off, sometimes in huge chunks as well. Next up, we've got abrasion. And abrasion is when the water actually comes into contact with the base of a cliff or a headland on a coastline, whilst containing sand or various particles of rock fragments. When they come into contact with the cliff face or the headland or the base of the coastline, they will hit the coastline and scrape down it like sandpaper, again removing particles along the way, just like you can see here. Next up, we've got attrition, and this involves the particles and rock fragments that are actually being transported by the sea and within the water. Now, when rock is being carried by the sea, they always have potential to bump into each other, to bash into each other, or to knock into each other. And when this happens, over a long period of time, they will begin to become smaller and more rounded as the constant bashing encourages attrition, this form of erosion, to take place. Some particles may even become too weak or become perfectly rounded and even break apart. And finally, we have solution. Now, solution is something we cannot always see in terms of an erosional process that happens on the coastline because it involves the seawater dissolving certain types of rocks. Rocks, for example, like chalk and limestone in the UK, are very prone to this type of erosion. And you've also seen in my previous demonstration in this video that sandstone is also susceptible to solution as well when it allows the water to turn a little bit of a murky colour. So on that note, everyone, I hope you found this video useful. Thank you so much for watching, and I'll see you next time.